So I've been making a lot of chess variants lately, and they all have one thing in common: squares. They're classic, logical, rigid, and easy to make a grid out of. But they aren't the only regular shapes that can be turned into a chessboard. That list is actually surprisingly small though, those shapes being hexagons, squares, and the most neglected, the triangle. The triangle is an interesting case. In order to make a grid out of triangles, you need to rotate every other one. So things aren't quite as orderly as you expect from squares, and it makes playing chess on a triangular board a bit counterintuitive. There are also some problems with the triangular grid. If you remove the lines in any one direction, it becomes a rhombic grid, which is effectively just a square grid. And if you take all the lines that meet at some of the points, you get a hexagonal grid. Basically, triangles are the imposters of the grid world, but they come with their own interesting properties. Hexagons and squares both have sets of parallel lines. In fact, every regular shape with an even number of sides does. Triangles, however, do not. So, what dictates horizontal, vertical, and diagonal movement? Well, there's no true answer, as you can't just follow the same rules that you would on a square board. For example, let's say for a forward move on a square board, the next square that you move along must always be connected to the previous square by the same corresponding side. If you try to follow this rule on a triangular board, you immediately run into a problem. How do you assign corresponding sides if the next triangle is upside down? If you assume the next triangle was rotated this way, then you would just bounce between the same two spaces infinitely. If you assume it was rotated this way, then you would just move in an infinite loop along the same 6 triangles. You could also say that a forward move means moving along a straight line perpendicular to one of your sides. Many of you would probably consider this to be the right answer, and I wouldn't try to argue with you. This keeps you moving in a straight line, and while it doesn't seem elegant when you think about how the movement actually looks on a board, it at least has some consistency with its even-sided counterparts. However, we run into a problem when we apply the same rule to diagonals. If we dissect the angle caused by the corner of the shape and move along that line, it's exactly the same as forward movement. Even though this may be the correct solution, it would make chess pretty boring, since bishops, rooks, and queens would literally be identical. So if we want the game to be true to the spirit of chess, we'll have to get creative. Let's circle back to one of the inherent problems with the triangular grid. If you remove some of the lines, it's just a rhombic grid, which is basically just a square grid. Now, let's apply the movement lines of standard chess to this grid and bring the triangular grid back, and boom, we have our movement. Almost. The lines we removed were actually fairly arbitrary and left out some movement possibilities. What we're really doing is combining a set of adjacent triangles to create a rhombus. And since each triangle has 3 adjacent triangles, there are actually 3 ways we can do this. So let's repeat the process for each of those and separate the diagonal moves for simplicity. When we lay these on top of each other, we can see that the triangular grid magically reappears. And with that, we have our movement. Another way to look at it is to think of the files as all of the spaces contained between the parallel lines caused by the edges of the triangular board. Also, for simplicity, I'm going to be calling these files for the rest of the video, even though straight lines are divided into both files and ranks on a square board. Using these rules, you can apply movement to each of the chess pieces in a fairly consistent way. For example, the rook moves along the 3 files like this. It's important to note, however, that the rook crosses over these triangles in a zigzag order, so it can be blocked by any piece along the file. As you might expect, bishops move along these 3 diagonals, and queens combine the movement of both the rook and bishop. This movement definitely has its quirks, and it's important to understand them if you want to transfer your square chess skills into triangular chess. And this is how the board is set up. The game is played on a triangular board made up of 81 smaller triangles, and pieces start on 2 of the 3 corners. One of the quirks I was just talking about is that the queen can checkmate a king without being defended, and this can happen in 2 different ways. In square chess, a king has a sort of bubble around it, where a king could never move into it because it would be moving into check. Whenever the opponent's king is either on the edge of the board or in a corner, the queen can easily checkmate by moving so that the king has no way to escape this bubble, as long as your queen is defended and the queen is not attacked by another piece. Since there is both an additional file and an additional diagonal in triangular chess, the queen has a much larger bubble, which allows it to perform this checkmate without the need for a defending piece. For reference, the king moves like this: one space along any file or diagonal. If the king is in one of the corners, the queen just has to be anywhere along this file. Anywhere else, the queen just has to be 2 spaces away from the king diagonally, as long as the king's triangle points towards the queen's triangle. The second quirk happens because of the way that files and diagonals are determined. For the first space, movement along files and diagonals are identical in many directions. That means that this bishop and this rook could both capture each other. This makes it a bit harder to attack these pieces, since an undefended piece generally needs to be more than 1 space away to safely attack a rook or bishop. So what about the knight? In order to translate this onto a 3-filed triangular board, we first have to fully dissect how the knight moves in square chess. In simple terms, the knight moves 2 squares in one direction, then 1 square in another. But to be overly precise, we have to break down movement into 4 directions along 2 lines. The knight first travels in one of these directions for 2 squares. Then, the knight moves 1 square in another direction, but it cannot move along the same line twice. I get that this definitely isn't an efficient way to explain how the knight moves, but bear with me. We can use the same explanation for the triangular knight. This time we have 6 directions of movement along 3 lines. So the knight moves along one of these 6 directions for 2 spaces, then picks one of the remaining 4 directions and moves 1 space. So using that logic, these are the moves that the knight can make. Simple. But hold on, one of the rules wasn't quite followed. Even though the knight doesn't explicitly move along the same line in this example, we run into the same issue that we had with bishops and rooks. Since the first space of movement is identical along several sets of files and diagonals, moving in this direction is basically the same as moving along the same line as the first 2 spaces, which effectively makes it so that the knight is allowed to move just 1 space. Because of this, I had to be more strict with the rules. The knight moves 2 spaces along any file, then moves 1 space outward along either of the other files. Using those rules, we finally have the knight moves that I ended up with. This is still far from perfect. If you look at all of these moves, you might notice something. All of these moves are either identical to moving 3 squares in one direction, or just 1 square diagonally. Not only does this still break the single line rule, but it also makes it so that the knight will never be able to attack a queen without the queen being able to attack it. This fact is what makes the knight so special in square chess, and I was disappointed that I couldn't transfer that over into triangular chess without significant modifications. The easiest solution to this would be to use a different property of the knight to determine its moves. In square chess, the knight moves to the first available squares that cannot be reached by a straight or diagonal move. In triangular chess, that would look like this. If you watched my last video, you would know that my philosophy with these variants is to make as few rule changes as possible. This puts me in a tough spot. In order to maintain the knight's primary use case, I would have to make a significant rule change. This is a change that I'll just have to keep thinking about. Now with that out of the way, there's just one piece left to talk about: the pawn. You know how I just spent the last minute talking about how I don't want to change the rules? Well, throw that in the garbage, because the pawn is somehow more complicated than the knight. In square chess, the pawn moves in a single direction towards the other end of the board, and it captures diagonally. If I were to stick as close to this rule as possible, I would have to allow the pawns to move along 2 files towards the opposite edge of the board, and have them capture diagonally. This runs into a couple of problems. The first is that since pawns can move in 2 directions, they can take several different zigzag paths to the end of the board. This makes the pawns a lot more unpredictable and erratic, which changes the gameplay a lot more than I'd like. And the second one is the exact same problem that we had with rooks and bishops. Again. Since pawns can only move 1 space, apart from their first move, their moves along files will always be identical to a diagonal move. This means that the pawns will never be able to block each other. The solution I came up with is far from perfect, but helps restore a lot of the pawn's function. All I did was switch the forward and diagonal moves. Pawns in triangular chess move along a single diagonal towards the opposite end of the board, and capture along 2 files. The diagonal still lines up with the files half the time, but they can still be blocked whenever they're on a dark triangle. The pawn promotes whenever it reaches any triangle along the entire file on the edge of the board. Thankfully, en passant still works exactly as you might expect. If a pawn moves 2 spaces, and your pawn would have been able to capture had it only moved 1 space, then you can capture en passant. Because of how the pawns are set up, there's even a scenario where you can en passant and promote in a single move. One final note. You may have noticed that the rooks are placed right next to the king, and the king is all the way in the corner. Since the mechanics would be awkward, and the king is already as safe as it will ever be at the beginning of the game, you cannot castle in triangular chess. And that's it. That's triangular chess. This is definitely the most I've struggled with defining a variance rule set, but it was pretty fun to make, and I think the results were pretty good. Triangular chess has been playable for a while now in the game that I'm making called Deckmate. If you're new here, I'll leave links in my Discord and Steam store page where you can get more info on how to play the open beta. If you'd like to support me in YouTube's algorithm, make sure to like, comment, subscribe, and check out my other videos. This has been a really fun project so far, and I'm really excited to continue working on it. That's all I have for now. Thanks for watching, and I'll see you in the next one.